In this video, we will discuss how to conduct an analysis of variance, or ANOVA. You will find as you conduct your analysis of variance that it is an extension of the t-test, and that we're looking for the variation between groups in relation to the variation within groups. But instead of just comparing two groups as with a t-test, an ANOVA allows us to compare any number of groups. You might wonder why we can't just conduct a series of t-tests among the multiple groups. We could, but there are two problems with this approach. First, it would be very time-consuming, and second, we would be increasing our chance of making a type 1 error. If you recall from the last chapter, typically a social scientist will accept that there is a 5% chance of making a type 1 error, or rejecting the null hypothesis when it should have been retained. When we conduct a series of t-tests, we are opening ourselves up to the greater probability of making a type 1 error, and nobody wants to do that. The ANOVA is a way of making a singular decision if there is a difference between the means of two or more groups. The research hypothesis for an ANOVA is that the means of any two of the groups differ. The null hypothesis for ANOVA is that the means of all groups are identical. An analysis of variance does not tell us which groups differ, it only tells us whether there are any differences between groups. In order to determine which groups differ, we need to do a multiple comparison of means and we'll cover that after we complete our analysis of variance right now. For our example today, I'm going to use a question from your textbook, which states, a researcher is interested in the effect of employment on satisfaction with marriage. He selects a random sample of 16 married adults who are employed full-time, employed part-time, temporarily unemployed, or chronically unemployed. He asked respondents to rate their satisfaction to marriage on a scale that ranges from 1, very dissatisfied, to 7, very satisfied. And so the scores for each of the groups are listed here. And at the bottom, we have the number that are in each group. So this N row is not part of the scores. So just keep that in mind. Analysis of variance is based on a type of variation called the sum of squares. Your textbook provides two formulas similar to the two formulas provided in the measures of variability chapter. There is a definitional formula, which emphasizes the idea between the sums of squares, but there also is a computational formula that just makes calculating ANOVA a lot easier. It's helpful to look at the definitional formula in your textbook to get a sense of what ANOVA is really doing, but for this example, we're going to use the computational formulas. These formulas make it much easier to calculate ANOVA from raw data. On the right-hand side over here, I have all the formulas needed to conduct an ANOVA, along with the follow-up test that will examine mean differences between pairs of groups. Not posted on the right is the formula for total sum of squares. Total sum of squares is equal to the within sum of squares plus the between sum of squares. So these two different groups formulas. And so we don't need to know the total sum of squares for this calculation, so it's not included. But we're going to calculate the within and between sum of squares. We could also add those up to find the total sum of squares if we wanted to. In order to conduct this example ANOVA, I'm following the step-by-step instructions found in your textbook. You might want to follow along in your textbook as we go through each of the steps. The first step in your textbook is to find the means for each group, and let's do that now. And just as we've done before, we're going to put an equal sign. I'm going to click on the average button. I'm going to select the 4 scores, not including the number, and the first mean is 6.25. I'll do the same with the rest of them. Okay, so we now have a mean for each of the groups. The full-time employed has a mean of 6.25 on the marriage satisfaction scales, and we go look all the way down at the chronically unemployed, have a mean score of 1.5. We're already seeing that there's some differences in the means, and now we just have to find out if they are significant differences. Step 2 asks for a sum of all of the scores, and to sum the scores in the 4 columns, I can put an equal sign and select sum. And I can select the scores in the first column, Hold the Control key down, select the scores in the second column, keep holding the Control key, and hold it a little bit more until we have all of the scores highlighted. Press Enter, and I have a total sum of scores of 68. And so if you went through and you added all these scores, it would come up to 68. That is our sum of scores. Your step-by-step guide then seeks the total N. And for this, we can add up the number of participants in each group. And I'm going to use the handy Control key. Oops, I skipped a step. I'm going forward in a step. Let me do this first. So I'm going to select 4, 4, 4, 4. Press Return, and our N total. Oh, it didn't work. Why not? I'm going too fast. I'm going to hit Sum. And press 4, 4, 4, 4. And our N is 16. Okay, the step that I skipped is step 3, which is to find the sum of x squared. So remember that sigma symbol means sum, and we have x squared for all of them. And so we're going to have to go through and find the squared scores individually first. So we've done this before. 7, hat 2. I'm going to drag it down. And I have the squared scores for the full-time employed equals hat 2. I'm going to drag down the scores here equals 5 hat 2, or caret, hat or caret. Drag down, and then equals 2 caret 2 for squaring. And then dragging it down. So now we have all the squared scores. Now to find the sum of the squared scores, I'm going to use the Control key again. I'm going to press Enter. I'm going to select the first column of squared scores. Oh, I did it again. What did I forget to do? I forgot to put sum. Okay. I'm going to select the first column of squared scores. Hold down on the Control key, select the second column of squared scores, the third column of squared scores, and the fourth column of squared scores. And we have a sum of squared scores of 348. Okay, and then step 4 we've already done with the N of 16. And now we're being asked to calculate the total average, or the average of all of the scores combined. There are 2 ways to calculate the total average. The first is to take the average of the averages. So we'll try that. I'm going to do an equal sign. I'm going to select my average button. And I'm going to hold on down on the Control key. I'm going to select the first average, mean, the second average or mean, third and fourth. Press Return. And I end up with a total mean, or an average of the averages, of 4.25. But this only works if your group sizes are equal. And in our case, our group sizes are equal, so we could have done that. But I'm going to show you another way in case your group sizes are not equal. And that is to press Equal. And what I'm going to do now is I'm going to sum up all of the numbers and divide them by the total N to find the average of all of the numbers. So I'm going to use my Control key and hold down on this. Oh, I need to do first average. There we go. Select the first 4 scores, hold the Control key, select the second 4 scores, the third 4 scores, and the fourth 4 scores. Press Return. Oh, what did I do? Okay. Oh, there you go. Found the average, 4.25. It was the same average as we had before because I had used the average function. And so now our total mean for the group is going to be 4.25. Now we're finally at the point where we can find our within sum of squares and between sum of squares, these first 2 formulas right here. It's one of those multi-step formulas, and so I've broken it down into 2 parts. And the first part of the formula asks us for between groups sum of squares from raw scores is to find the sum of all the group n's times their mean squared. So to do this, I'm going to enter an equals, and then I'm going to take one group at a time. And this is the part that probably requires a little bit more attention because it can be a little bit confusing. So I'm going to do an equal sign, and I'm going to select the number of the first group. I'm going to multiply that by the mean of the first group, but not just the mean squared. So the first number I have is the number 4 times the first mean of 6.25 and then squared. But I need to add that. I need to sum this all up, so I'm going to put a plus sign. And I'm going to do the exact same thing for the next group. The number 4 times the mean of that group squared. We need to do the same for the other two, so I'm going to do a plus sign. The number 4 times the mean of the group squared plus the number 4 times the mean of the group squared. And that gives us the first half of the between sum of squares formula of 336.5. The second part of the formula is asking us, it's probably easier to see over here, the n total times the mean squared total. So what we're going to do is simple enough. I'm going to put an equal sign. And we have our n total already, which was 16. We're going to multiply that by the total mean, but we need to square that as well. And we end up with the second half of the formula for between sum of squares at 289. So to finish this out, we just need to subtract 289 from 336.5. So let's do that. 336.5 minus 289. Oh, I've got it in the wrong spot. Let me do that again. Here we go. This minus this equals. Okay, so we now have our number for the sums of squares between groups, which is 47.5. And the next thing we need to find out in your step-by-step formula is the within group sum of squares from raw score. So now we're looking at within group variation. And for the within sum of squares, we've already calculated the first part of the formula, which is the sum of the squared scores. The sum x squared, we have that right up here, 348. So I'm going to put an equal sign, and I'll just steal that number. And that's the beginning of it. And you will recognize the second half also as the sum of n group plus the mean square of the group. And so where do we see that? We see that term. So we see for this en group, x squared group, and we have that same formula right here. So I'm going to steal that number as well. Okay, and so to finish out our sums of squares within, we're going to simply subtract the formula parts. So we've got 348 minus 336.5. And so our sums of squares within is equal to 11.5. The next step is to divide each of our sum of squares by their respective degrees of freedom, which will give us what is called a mean square. We do this because the sum of squares calculations can be inflated simply by sample size. The more people you have in your study, the higher your sum of squares is going to be. And so we use our degrees of freedom, which is based on sample size, to control for the number of scores involved. So first, let's find the degrees of freedom for both between and within sums of squares. For between sums of squares, the degrees of freedom is equal to k minus 1, where k is the number of categories or groups. In this case, we have 4 groups, so I'm going to just simply equal 4 minus 1, k minus 1, and our degrees of freedom for between groups is 3. The degrees of freedom for within groups is calculated by the formula n total minus k, or the number of groups, In this case, our n total, we already know, is 16. And the number of groups that we have is 4. So our degrees of freedom within are going to be 12. So we have degrees of freedom of 3 and 12. Since we now have our degrees of freedom for between and within, we can find the mean squares for each by dividing the sum of squares by the degrees of freedom. And so we're going to start with the mean square for between groups. And I'm going to just put an equal sign, and I'm going to select the sum of squares for between, which was 47.5. And I'm going to put that over the degrees of freedom for between, which is 3. And so our mean square between groups is 15.83. And I'll do the same for the mean square within group, equals. I'm going to select the sum of squares within and put it over the degrees of freedom within. And so our mean square from within, for within groups, is 0.96. And finally, we're going to get to calculate the F statistic. It's been a long process, but we're here. And the F statistic is very similar to a T statistic, and then it's simply the ratio between mean squares between and the mean squares within. So we'll just divide the between by within now, and we will see what we end up with. So we have equals, and we're going to select the mean square between over the mean square within, and we end up with an F score of 16.52. And we call that sometimes an observed F of 16.52. And now that we have the F value, just as with the t-test, we compare our calculated statistic to a critical value which we obtained from a table in our textbook. The table entitled Critical Values of F at the 0.05 and 0.01 significant levels can be found in Appendix C. And we'll take a look at that right now. But before we do, in order to find the critical F, we need to define the degrees of freedom for the numerator and the denominator. For the ANOVA, the numerator refers to the degrees of freedom between, right here, and the denominator refers to the degrees of freedom within. So you might want to make a note of that in your textbook so you can remember that easier. So for our example, the degrees of freedom between is 3 and the degrees of freedom within is 12. So let's take a look at the table for the F statistic. And so for the numerator, we're going to go across the top, and our numerator was 3 and our denominator was 12. So I'm going to go from 3 down to 12, and I see a critical F of 3.49. So let's enter that into our spreadsheet, 3.49. Okay, so our question now is, are we going to reject or retain the null hypothesis based on our observed F compared to the critical F? And since our observed or calculated F is 16.52, that is much greater than 3.59. So we can reject the null hypothesis that there are no differences in the means of the groups. This means there was a difference or multiple differences between groups, and therefore rejecting the null hypothesis. We now have to determine where those differences are. And we do this using something called Tukey's HSD, or Tukey's honestly significant difference. For a field such as statistics that uses such far-out terminology, honestly significant difference seems weirdly descriptive, but I digress. Here is the formula for Tukey's HD. And this formula gives us a number that will tell us how big the difference between two groups must be in order for that difference to be significant. And the only value that in this formula that we don't have is something called Q. Q is also found in the table for Q, is also found in Appendix C in your textbook. It is entitled Percentage Points of the Studentized Range Q for the 0.05 and 0.01 levels of significance. It's a mouthful. In my textbook edition, it is Table E, but it might be a different table in your textbook, so just look for Q in the title. To find Q, we need degrees of freedom for within and the number of means. In our case, the within degrees of freedom right here is 12, and the number of groups is 4. So I'm going to pull up the table now for Q, and I'm going to look for the number of means. We had 4, so this is going to be this column, and the degrees of freedom we have is for 12. All right, so we have two numbers right here, 4.2 and 5.50. And as we look over here to the left, we see 0.05 and 0.01, and that's for the different levels of significance that you might be looking for. We're going to go for the 0.05 significance level, and so our value for Q is going to be 4.20. So let's just plug that in. Our Q is 4.20. All right, the formula for Tukey's honestly significant difference is right here. It's going to be Q times the square root of the mean square within over n group. So let's take a look and see what that works out to be. So I'll start off with an equal sign. I'm going to select Q. And then the next thing I'm going to do is find the square root. So it's going to be times the square root. I'm going to do times SQRT. And then I'm going to put everything that's going to be in the square root term in a parentheses. So there. And we're going to select the MS within, which was 0.96, and over the N group. And N group in this case is going to be the number of participants in each group, in one group, for example. This works when you have groups of the same size. So I'm just going to select one of them for 4, close the parenthesis, and there we go. So our Tukey HSD is actually going to be 2.06, and we're going to talk about what that is in just a moment. I will also mention that if you did have groups that had unequal ends, that would be problematic with this number right here. So there's something you would calculate called a harmonic mean. And to keep us all in harmony, we're not going to go into that right now. But so that's why we were able to use 4 right here, is because all of the groups had 4. So that seemed to work out just fine. Tukey HSD for us is 2.06. So our final step is to determine which groups are different by at least 2.06. So let's do some quick calculations. And to do this, I'm going to go up just a bit. There we go. I'm going to do, for example, the full-time person minus the part-time person to see if the difference between those two means is greater than 2.06 equals. So I'm going to do the mean of one minus the mean of the other. And the difference there is 1.5. So that does not exceed 2.6. So there's not a significant difference between full and part-time people. Let me try another one. Full-time people to the temporarily unemployed. Make that a T. So we're going to go equals full-time minus the temporary unemployed. And that difference is 1.75, and we still do not reach the Tukey HSD of 2.06. So there's not a significant difference between full-time employed people in their marital satisfaction and temporarily unemployed people. Let's try one more. Full-time to the chronically unemployed. So we have full-time minus the chronically unemployed. And now here's where we finally do see a significant difference. So we have 4.75 is the difference between the marital satisfaction of full-time workers and chronically unemployed workers. And so that exceeds the Tukey HSD of 2.06. And so that's where at least one of our significant differences lies. Now, just eyeballing the rest of them, I can see where the difference is going to be. It's going to be between the chronically unemployed and all the rest of the groups. There's going to be more than 2.06 between the chronically unemployed and the temporarily unemployed, the part-time and the full-time. So this is where the action is actually happening. This is the group that is significantly different from all the other groups. So in conclusion, we can reject the null hypothesis that there are no differences between groups, and using Tukey's HSD, we can see that there's a significant difference in mean marital satisfaction between the chronically unemployed and all other groups. Okay, do you have a headache yet? You might be feeling really sorry for statisticians right now, but the truth is we can calculate ANOVA with one click of a button using statistical software. Amazing, I know. But a click of a button won't show how ANOVA is calculated, so pat yourself on the back for hanging in there with this very complex procedure. Because it is complex, there are only 3 items on this week's homework. The first item is actually an example. It is done for you already, so you can click on the cells and see how things were calculated. The second item is from this video, so hopefully you've completed it as we've gone along. You're somewhat on your own for the third item, but I have provided all the supporting steps and formulas so that you can be successful. Good luck, and bring any questions to the discussion board. And this is probably, as I mentioned before, the hardest week in terms of calculation, but you can do this. This is just a matter of hanging in there, following directions, and having a little bit of patience, and you'll be calculating an ANOVA in no time.